section 3.4a, so it's the correct topic for section 3.4. So we have 3.4a, which is going to be simplifying and multiplying rationals, and then we have 3.4b, which will be finding least common denominators of rationals. Rationals, the root in rational is ratio. So basically, they're, instead of polynomials like we're used to seeing, like ax squared plus bx plus c, they're ugly expressions where we have a numerator and a denominator. So real quickly, I just kind of want to remind ourselves how we cancel or simplify. Is if you can break it down to a product, AC times BC, we can actually cancel out the c's because any number over itself is just 1, right? And then you can reduce it to A, B. But the words really are what is important. It says, in words, the only time that a fraction can be reduced is when the item that's being canceled is a factor of the entire numerator and the entire denominator, meaning multiply, okay? So if there's a plus or minus there, we have to be able to factor something out first. So how I teach this in my other class is probably a little bit different than how I need to teach you guys. But I'll do it anyway. So when I go to cancel or simplify, guys, I just break things down to primes. So what's the prime factorization of 6? Well, if you did your factor tree, what two numbers multiply to be 6? 2 and 3, okay? And then x cubed is 3 x's. There he is. And then y squared is 2 y's. There he is. I'll show you a shortcut with the variables here in a second. I think I saw you do it, Gavin. I do it the same way. All right, 15. How does 15 break down into a product of primes?
3 and 5.
3 and 5. And then you have 1x, and then you have 5 y's. Okay? So all you do when you're factoring, or excuse me, canceling or simplifying, is any number on top that matches a number on the bottom cancels, and they don't have to be directly over each other, okay? So this 3 and this 3 cancel because that's a factor of 1. This x and this x cancel because that's a factor of 1. This y and this y cancels because that's a factor of 1, and this y. And you can be putting 1s everywhere, but it just kind of clutters it up. Once you go through and factor, or excuse me, cancel all the common factors, then you just multiply straight across the top what remains and straight across the bottom what remains. So up top we have 2 times x, or 2x squared. On the bottom you have 5 times y times y times y, or 5y cubed. Does that look okay? So what's a quick way? Do you have to do it this way? No, I think you guys are at a level where you don't have to break it down this far. One way to look at it is look at 6 and 15 and ask your guys, what's the biggest number that goes into both of them? 3. So 3 goes into 6 2 times, so that's why a 2 remains. 3 goes into 15 5 times, that's why a 5 remains. And then as far as variables go, I like to think of it as like a punching match where whatever x or y they're fighting each other, they're going to knock out 1 or 2 or 3 of the others, but whoever has the most remain, that's where they remain. For example, this x on bottom will knock out 1x of these, but he has more, right? So he'll take out 1x, but there's still 2 that remain, hence x squared. And then these 2 y's up here will knock out 2 of the y's down here, but he still has 3 more, so that's why it's y to the third. Okay, that's kind of how I think of it. So they'll always knock out that many, but whoever has the most, that's where they'll remain, on top or bottom. Okay, so how do we do the rest? The rest is just going to come down to factoring, okay? So how can we factor 6? That's just 2 times 3 times x. And then this is just a GCF. What can you take out of 3x squared and 12? 3. So pull out a 3, and then when you do that, what's going to be left? X squared plus 4. So could you guys see that common factor of 3 that we can cancel out? So since this is multiplied on top and this is multiplied on the bottom, 3 over 3 just makes 1. Okay? We can't cancel out that 2 with that 4 because they're not being multiplied. That's not really a 4. That's just 4 plus whatever x squared is. Okay? So x squared could be 9. 9 plus 4 is 13. That's not going to cancel out with a 2, right? So if there's a plus or minus there, you're not going to cancel out. So what's our final answer, guys? 2x over x squared plus 4. And you can have no, or you can have the parentheses there. So since once we took the 3 away, nothing else was really happening to the x squared plus 4, we really don't need the parentheses there. All right, we're just going to keep doing that, guys. What's the GCF that we can take out of x squared plus 3x? An x. When you factor him out, what are you left with? X plus 3. Beautiful. On the bottom, what can we factor out? An x, and what are you left with? x plus 6. So what can we cancel? The x's. And so your final answer, guys, is just x plus 3 over x plus 6. And again, you might be compelled to cross out the x or cross out the 3 and the 6. No, 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 no. Say x was 1. That would be 4/7. That doesn't reduce, right? So only cross them out if they're being multiplied. We're going to do the same thing down here. All right, what can we factor out of the top? We just did it, right? What can you factor out? X. And then, guys, just for purposes of saving time, you guys are all so good at the AC method. I'm just going to give you the answer and just tell you that I did it with the AC method, okay? So, like, we don't have to do it. But what if factors of 3 that add up to 4? 3 and 1, you'd rewrite it, factor by grouping, okay? This would factor to x plus 3, x plus 1, okay? So for purposes of time, we won't spend it using the AC method, but that's how you'd go about factoring the bottom. All right, what can we cancel out? A factor of what? The x plus 3's, okay? Do you see, like,
Oh, yeah.
he's, like, piggybacking on him, so this x plus 3 is going to cancel with that x plus 3, so what are we left with? X on top, and what on the bottom? X plus 1. All right, the next one, that's one of those things I want you guys to recognize because you'll see it here and in your other classes. That's a difference of 2 squares. Remember the difference of 2 squares are those open arm parentheses? What's the square root of x squared? How can we split x squared up evenly?
Divide.
Not divide, but we'll just be x and x, right? It's the square root. What's the square root of 4? 2. And what do I need in order for the middle term to cancel out? Plus or minus. And then this is all over x plus 2. So what can I cancel out?
The
X plus 2's. And since x minus 2 is on top, I don't need to put him over 1. He's just x minus 2. Is that okay? So if he's left on top, we don't write it over 1. All right, so last one here, guys, this is kind of different. I'm going to do it this way once, but I'm going to just tell you that once you notice it, you don't have to ever show work. You can just cancel them out. The answer here is -1, and I'll show you how it works, okay? So leave n minus 5 alone and switch the order of this. So this is -n plus 5. Do you agree? I just put my n in front, but the n sign was negative, and I put the 5 in back. And you guys notice that the n's match, the 5's match, but it's opposite signs, right? What we're technically doing, so again, I'm going to do it this one way, and just you never have to do it like this again. Leave n minus 5 alone, but factor out a -1 from the bottom. What's a negative n divided by a -1? A negative divided by a negative turns to be a positive n, right? And then what's a positive 5 divided by a -1? What's a positive divided by a negative? Nope. Negative. Okay? When we cancel them, we're canceling out, this is technically a factor of 1, right? So we have 1 over -1, which is just -1. This is something, guys, when what you have, they are flip-flopped completely, meaning the n signs are opposite and the 5 signs are opposite. There's a back, Riley. They just differ by a negative. So, like, I would be okay with you cancel, and then you put like a -1 up there. You don't have to do all this work, and I'll show you that, I think, on this next page. All right, so let's just do the back real quick, and then we can be done. So before we get going, there's rules for multiplying fractions, and the rules for multiplying fractions is multiply straight across the top, a times c, and straight across the bottom, b times d. Okay? So the rule for multiplying, guys, is multiply straight across the top, a times c, and straight across them, b times d. But I'm going to show you a shortcut. We can actually just do it with our calculators, which is kind of nice. So real quickly, guys, though, we can do this. What's 5 times 3? 15. What's 2 times 7? 14, and you're done, okay? So these ones down here, where they're just straight up numbers, we can do in our calculator, but we want to make sure it's a reduced answer. So in your calculator, if you would, do 14 divided by 15 times 45 divided by 7, and then hit the math fraction key. And I'm going to do it by hand up here. I'll show you how I do it by hand. You get 6 over 11. Mm-hmm. So how I I do it by hand, and you don't need to be doing it by hand. The other class I teach, they're not allowed to use a calculator, so we have to be able to do stuff by hand. But how I do it by hand is I multiply straight across the top, straight across the bottom. But instead of multiplying the numbers in a big way, I multiply their primes. What do I mean by that? What's 14? It's 2 times 7. What's 45? It's 9 times 5. But what does 9 break down to? 3 and 3. So here's 14 times 45. And then down here, what's 15? 3 times 5. Down here, what's 77? 7 times 11. And by breaking them down from primes in the beginning, I can easily see what cancels, whereas if I didn't have my calculator, it's a little bit easier. Okay, but not everything's going to be that way. So what we want to pay attention to is the same kind of idea here. You can do the number part on your calculator. So you can do 22 over 7 times 14 over 11. Will you tell me what you get for that answer, guys? 22 over 7 times 14 over 11, hitting math frac.
4.
4, is that okay? So that's the number part, right? But then we have to focus on, are there going to be some A's left? And if so, where will they be? Well, notice the A's on the bottom. There's only 2, okay? He's going to knock out 2 of the A's on top, but there's going to be 3 A's, and it's going to remain up there at the top with the 4. Is that okay? So A to the 3rd. Because he will knock out 2 of those, and that will leave a 3. Is that okay? If it was flip-flopped, so say there was A to the 5th on the bottom and A squared on top, you'd have 4 over A cubed. All right, so from here on out, guys, all we're going to do is the same thing, but we're going to cancel out common factors. So this is just going to be x times x plus 4 times x, all over 1 times x plus 4. Okay? So I'm just multiplying straight across the top, x times x plus 4 times x squared, which is just x times x, all over 1 times x plus 4. Well, what's the only thing that cancels out on top and bottom? The x plus 4s, right? So what are we left with? X times x, or x to the 3rd, over 1, but we don't really write over 1. All right, here, instead of rewriting it all out, you can kind of see it already, right? What's going to cancel out on top and bottom? N plus 5s, and the only thing that's going to be left is n times n minus 7, which they should take, but if they want you to distribute, let's write the distributed answer, or if we distribute, that would be n squared minus 7n. Is that okay, guys? So the n plus 5s canceled out, and you're just left with n times n minus 7, which they should take. But for some reason they want you to distribute, just go ahead and distribute that n to get n squared minus 7n. All right, last one here, or the last two, I am going to write it with factored form, okay? So let's go ahead and factor this. What GCF comes out of there? If we just focus on him. X, and what will we be left with?
X
plus 1, right? Because we have to factor him out. So x times x is x squared, x times 1 is x. So he's factored, right? And then times 4. And then on the bottom you have x plus 1 and x plus 8. Is that okay? So we do all that, and what's the only thing that's going to cancel? X plus 1s, exactly. So what remains on top is x times 4, but we typically put the coefficient in front, so 4x, all over x plus 8. And again, as much as you might want to cancel out the 4 with the 8 or the x with the x, you can't. Because say again that x was 1. That would be 4 over 9. That doesn't reduce any further. All right, last one. This is what I was talking about. Do you notice on the bottom that x minus 3 looks really similar to the 3 minus x, but everything's just flip-flopped? So here what we're doing, and I don't have you do it because things would get cluttered, but technically when they match perfectly, that's a factor of 1. Okay? So we're doing x times 1 times 4. Or down here we're doing x times 1 times x times x. So here, whenever they match perfectly, but everything's flip-flopped. For example, here's a positive x, but here's a negative x. Here's a negative 3, but here's a positive 3. We can cancel them out, but they cancel by a difference of a negative, okay? So we'll just cancel them out, and we'll put a negative 1 there. But remember, we multiply what's left. So what's 6 times negative 1? Negative 6 over 5. Okay, and that's what I was talking about, where on the bottom of the front page, this is kind of proof of why it works, but we never need to do all that work.